Welcome back. This is the second lesson recording for IM2, February 25th, 2021. Okay, so we've just solved the more complicated solve using square rooting. So you're going to take notes on solving this problem. Another example. Alright, so if you have 4 multiplied by x plus 2 all squared minus 5 is equal to 19. What are the steps involved? Please take notes on this. The first step is to rewrite the equation as something squared is equal to constant. Okay, you can have something that is inside the parenthesis, an expression that's being squared that is equal to constant. So in this case, I am going to bring negative 5 to the other side by adding 5 to both sides, and then you're going to divide 4 on both sides, and you're left with x plus 2 all squared is equal to 6. Then from here, the second step is to apply square root on both sides, just like what you've done last lesson. So you take a square root of both sides, but make sure you include both positive and negative version by putting the plus and minus sign. So you're taking square root of both sides, adding the plus and minus side on the side with the square root of a constant number. The square and square rooting cancels each other out, and left hand side you're left with x plus 2. On the right hand side, square root of 6. 6 is not a perfect square, and nor does it have any factors that are perfect squares. So you leave it as square root of 6. So x plus 2 is equal to plus or minus square root of 6. Then from here, you solve both versions separately. You do need to write the equations separately. So x plus 2 is equal to positive root 6, or the other possibility is x plus 2 is the negative version, which is a negative square root of 6. Then from here, you are going to subtract 2 from both sides, and you are going to be left with x is equal to negative 2 plus root 6. On the right hand side, x is equal to negative 2 minus root 6. Notice that this is not just a plus. The answers are a little bit more complicated than before. Alright, so please pause the video and take the notes. Now you're going to try to do this yourself. Okay, I would like you to work on paper, then put your answer in private chat. So you're given 2 different problems, and you have to solve them by giving me the values of x. Please pause the video and do them now. So here we go. We want the square term on the one hand side with a constant on the other side. So in this case, I need to bring the negative 4 to the other side by adding 4 to both sides. So that becomes x plus 5. Adding 4 to both sides, and that becomes x plus 5 all squared is going to be equal to 46 plus 4 is 50. Okay, now from here, I need to take square root of both sides. Remember, when I take square root of both sides, I need to leave a plus or minus sign on the side with just the number. So the square and square rooting cancel each other out, and you're left with x plus 5 on the left hand side of the equal sign. That is equal to plus or minus square root of 50. Now square root of 50, this is not a perfect square, but it does have a factor that is a perfect square, which is what? It's 25 and 2, right? So that means this can be simplified to plus or minus square root of 25 is 5, and square root of 2 is just itself, so square root of 5 root 2. Now I rewrite the two equations separately. X plus 5 is equal to the positive version, which is plus 5 root 2, and x plus 5 is equal to negative version 5 root to negative 5 root 2. Then I need to subtract 5 from both sides, and that leaves me with, okay, so that leaves me with x is equal to negative 5 plus 5 root 2. Okay, remember I cannot simplify this further. Okay, I can factor out 5, but that's probably not really going to be useful. I cannot simplify this further because 5, just a number, and the radical being multiplied to a number, they are not like terms. Okay, or not, they're not like radicals. They're not like radicals, so that means that's the simplest form that I can leave it. Again, I'm going to subtract 5 from both sides here, and that cancels out, and you're left with x is equal to negative 5 minus 5 root 2. And that will be my answer there. Okay, let's try the other problem. Same process. We want just a square term on the left hand side, and we want just a constant on the other side of equal sign. So therefore we want the negative 12 brought to the other side by adding 12 to both sides, and that leaves me with 2 multiplied by 2x plus 3 all squared is equal to 32. Then from here I am going to divide both sides by 2 because I know that 2 is being multiplied to the squared term. That leaves me with 2x plus 3 all squared is going to be equal to 32 divided by 2 is 16. Now when I take a square root of both sides with, don't forget the plus or minus sign. Okay, squaring and square rooting, they cancel each other out, and you're left with 2x plus 3 is equal to square root of 16 is 4. So you have two different equations. Again, you need to write them out. The answer is not going to be the plus and minus version. It's going to be quite different. So that means it's going to be 2x plus 3 is equal to positive 4, or 2x plus 3 is going to be equal to negative 4. So I am going to subtract 3 from both sides, and that leaves me with 2x is equal to 1. And then divide both sides by 2, and you're left with x is equal to half. On the right hand side, I am going to subtract 3 from both sides, and that leaves me with 2x is going to be equal to negative 7. Then divide both sides by 2, and you're left with x is equal to negative 7 over 2. Okay, so which is negative 3.5. Notice that numbers are very different. Okay, it's not just a plus or minus half. It is plus half and minus 7 over 2. That is the reason that it is very, very important that you separate each of the equations separately and then solve for x. Finally, I am going to introduce you the third method for solving quadratic equations, and that is using quadratic formula. So if you have a quadratic equation that is in standard form, that is equal to 0, where a is not equal to 0. If a is equal to 0, this is no longer a quadratic equation. So we're looking for quadratic equation in standard form. If a equation is not in standard form, you need to convert to standard form and set it to be equal to 0. That's what you need to do. And then you're going to use this formula, x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? And if you have a quadratic equation in this form, the left hand side is in standard form and the right hand side is equal to 0, and then I can use this formula to find the two solutions. So let me walk you through an example, and you're taking notes on this. So solve using quadratic formula. Okay, so if you have x squared minus 3x minus 2 is equal to 2, the first thing you need to do is rewrite the equation in standard form on the left hand side and set it to be equal to 0 on the right hand side. So that means I need to get rid of this 5 by subtracting 5 from both sides, and so that leaves me with x squared minus 3x minus 7 is equal to 0. Step 2 is to identify a, b, and c. Remember, a is just a number in front of the x squared term. What is the value of a in this case? What is the number that is being squared to x squared? There is no number. That means the default number is 1. Okay, so a is 1 in this case. B is the number, just the number, not the x or anything else. B is just the coefficient that is being multiplied to x. So b in this case is not 3, but it is -3. Remember, the negative sign goes with the number that is following. So b is equal to -3. And then what is c? C is again not just 7, but it is -7. So you need to identify a, b, and c separately. Then you use the formula, which says x is equal to -b plus or minus b squared minus 4ac all over 2a. Okay, what's a b? B is -3, and a is 1, and c is -7. And I am going to use parentheses, and this is really important. I know a lot of students, they say that, oh, I don't need to use parentheses. I already know what I'm doing. And that's how you make mistakes, because though this is really straightforward and easy, it is very, very prone to error. Little silly mistakes where you are losing the negative sign or whatever else. So I am going to insist for now that you need to be using parentheses when you're substituting in the value, especially when you're dealing with negative values. So I am putting in -3 in parentheses here, and -3 is all being squared, and minus 4, a is 1, and c is -7 all over 2a. Then you simplify. Okay, so when I simplify, negative of -3 becomes +3. -3 all squared is not -9. This is same as -3 times -3, which is +9. And 4 times 1 times -7 is -28. And you take a negative of -28, that becomes +28. So you're adding 28 to it. So 9 plus 28 under the square root sign, all over 2 times 1 is just 2. And inside the radical, or the square root sign, 9 plus 28 just simplifies to square root of 37. So the final answer is 3 plus or minus square root of 37 over 2. I cannot simplify square root of 37 anymore, because 37 is not a perfect square, nor does it have any factors that are perfect square. And I cannot factor anything else out, so this is left as 3 plus or minus square root of 37 over 2, which actually means that x is 3 plus square root of 37 all over 2, and the other x possibility is 3 minus square root of 37 all over 2. Okay, so at this point, I would like you to do these problems using the quadratic formula. So please pause the video and solve them yourself. And I am going to go through the answers in our next lesson recording.